Yes, sir.
Okay. Just waiting for a few more minutes for other people to join, and then I will start. Well, can you see the screen here? Is it visible to you?
Yes, sir.
Okay. Okay. So we are starting this issue of Pigovian fee, which was actually made popular by Arthur C. Pigou, the English economist. Yesterday we had actually discussed about this. So basically, Pigovian fee is a part of the economic incentive scheme. So in essence, you can say that out of the two broad categories of pollution control measures, economic incentives is one more prominent one. Although the use or application of these economic incentives is relatively less compared to the command and control policies. Now here, in the case of Pigovian fee or fee, as we normally call it, so basic idea is to tax or impose fees on the people or maybe the economic activists who will be engaged in generation of pollution or emission, whatever it may be. Of course, emission and pollution are interlinked although we are more concerned with the pollution part. But if you have to control generation of emission and thereby kind of impact of pollution, obviously you may have to control emission. So that is why. So based on this emission level, how much one has generated pollution or maybe emission, based on that, the fees will be imposed, and that is known as Pigouvian fee. Now, for better understanding of this Pigouvian fee, already yesterday we talked about this kind of abatement cost, and we talked about the demand function, marginal demand function, as well as marginal abatement cost, which actually defines the equilibrium amount of pollution. And the idea here was to reduce the summation of the damage as well as the abatement cost. Okay, so marginal abatement cost. So overall, from marginal abatement cost, we get the total abatement cost. So total of this abatement cost and damages. So these two are to be reduced. And objective will be to get this value as minimum as possible. Now, to give an alternative interpretation to this issue, we would like to take help of a model which is represented before you out here. So where it is assumed that there is some kind of economic activities going on, and these economic activities might be in the form of production or consumption. Here, for our convenience, we are assuming that this is a kind of production activity. A factory is engaged in producing certain commodities. Now, normally pollution or emission is considered to be part of, it's considered to be a residual activity. Whenever there is some kind of economic activity, that is also accompanied by some kind of pollution or emission. So here also we assume like that. What we assume is that the factory is generating pollution in the amount of X and goods output in the amount of Y. So there are two production, in essence, you can say so, X amount of pollution and Y amount of goods. Now, the production cost for the factory will depend on the values of X and Y and also the input prices. Because for production of any goods and services, you will require input or maybe kind of raw materials. For example, we talk about leather industry, so you'll be requiring leather and so many other things will be required. Okay, so that will decide on the amount of the cost in the process of production. But here, of course, what we are assuming is that the input prices are constant. If the input prices are constant, we can consider this cost to be a function of. If we consider cost to be C, then this C will be a function of the amount of X and Y. That means the amount of goods produced and the pollution generated. Okay. Of course, what we can do, we can further simplify the things for our own convenience. So we can assume that since Y is nothing but the output produced and Y is also generating X, so we can say that for generation of X amount of pollution, the cost is given as C. C is equal to C, which is a function of X only, because Y is coming, so Y will be coming along with that. So obviously, when you talk about this total cost to be dependent on the amount of pollution generation, then we can always find out the marginal cost of generation of an additional amount of pollution. So that can be given as marginal cost MC, which is a function of amount of pollution which is generated. Now, of course, so it has a lot of interpretations. So we normally believe that this marginal cost can also be considered as the negative of marginal savings. In essence, we can say that marginal savings, which might come out of X, basically the pollution, so that might be equivalent to negative of marginal cost of production of pollution or generation of pollution. Another way of thinking about this is in terms of kind of, you can see the willingness to pay by the people out there. Of course, that will be in terms of damage function. Of course, we will come to that a little bit later. So whenever there is pollution or factory there, then obviously, so there might be certain kind of damages to the society at large, because emission will take place and this emission will have negative impact on the society as a whole. So for that, am I audible to you? I hope you are. I am audible to you.
Yes, sir.
Okay. So we assume that there are a number of people around the factory which might be exposed to the pollution generated by the industry or the factory out there. Now, if there are n number of people, since pollution is a kind of non-exclusive kind of a thing, so that will affect everybody in the surrounding of the area. So that is how so everybody in the vicinity will be subjected to the pollution generated by the factory out there. So for any person I, for example, the damage from pollution can be written as DIX. So where X is the amount of pollution generated, and this pollution will be having an impact on the society at large. So it might be in the form of air pollution, it might be in the form of water pollution, it might be in the form of some sound pollution, whatever that may be. If it is a factory which is emitting smokes or smokes, probably air pollution will take place, and this air pollution will obviously be directly linked with the human health. So that way, in fact, we can consider the damage function. So that, of course, directly cannot be estimated. What we can do, probably if it is a health-related issue, so if it is associated with air pollution, so it might be associated with health, and then the amount of cost which might be spent as health expenditure by the people out there. So that can be considered as equivalent or maybe as a proxy for the damages done by this pollution generation out there. So here, what we'll be assuming that for an individual I, the damage for him will be given as DIX. Okay, so that is considered to be positive, and that is also considered to increase with higher amount of pollution. So that means if X increases, the damages from the pollution generation will obviously increase. Alternatively, damages can also be considered to be benefits. So these benefits can be written as BIX. So where actually benefits in a sense, it will be negative benefits. So it's not benefit in a sense cost, and cost can be written as negative benefits. So we can say that this is minus BIX. So this benefits will be decreasing with higher amount of X. So more the pollution level, the lesser benefits will be there, or benefits will be decreased. In other sense, we can also consider this DIX as the willingness to pay to eliminate the pollution in the surrounding. So there are so many interpretations which can be given. Similarly, in case of this CX value also, sometimes we can say that this is the control cost or maybe abatement cost that we discussed yesterday. So here in this particular example, we are considering this to be the pollution generating cost, but it might also be considered to be the pollution control cost or abatement cost, which is incurred by the society or maybe by the company or by the factory for controlling pollution generation. Now, the damages to the society will be given by the summation of the damages of the individual members in the society or maybe in the neighborhood. So that is why, so if we have to take into account the total damages in the neighborhood of the factory, then we have to take into account that as probably DX, which will be nothing but the summation of all the individual damages of the people surrounding the factory. So if we consider DIX to be the amount of damages for an individual I, so for n number of people, then obviously we have to find out the total damages, which will be nothing but the summation of the individual damages. That is given as summation DIX, where I varies from 1 to n. So now our objective as a whole for optimality will be to find out that much of pollution level which will minimize the pollution generation cost as well as the damages to the neighborhood. Okay, so this is a kind of specific example, so that can be extended to bigger population as well. In this case, the obvious objective will be to find out the amount of pollution which will minimize the summation of the pollution generating cost and the damages to the society as a whole. So which is given as Cx plus Tx. So that is the objective function out here. For minimization of this, we know the basic differentiation principle we have to follow. And if we do that, we will find out a condition which is given in equation number 3, where we find the marginal damage function of generation of X amount of pollution, marginal damage function from an amount of pollution equivalent to X star should be just equivalent to the negative of marginal cost of generation of pollution equivalent to X star. So since marginal cost is also known as negative of marginal savings function, so what we can say is that this marginal negative of marginal cost function can be considered to be marginal savings function. And if we are talking about this dx star is nothing but summation of dix. So obviously this mdx star is nothing but, basically we can consider this to be the summation of all individual damages, marginal damage functions. So we can rewrite the equation as equation number 4, where it is written as ms x star is just equivalent to summation of mdi x star. So here, so this condition is the one which will give us the appropriate amount of pollution which should be generated in the society or maybe in that particular vicinity of the factory. So basically, the total cost and damage can be minimized at a level of pollution where marginal savings to the farm from pollution, basically marginal control cost in essence you can say so, is equal to the marginal damage from pollution over the entire population. Now, as we know, the pollution is a public bad, just opposite to public goods. In case of public goods, positive externalities are there. In case of public bads, negative externalities are there. Anybody and everybody can get the taste of this negative externalities. The pollution affects each and everyone. So that is why this aggregate marginal damage function is the vertical sum of the individual marginal damages. So that is how this appropriate amount of pollution we can talk about, or maybe optimal amount of pollution level we can talk about. Now, once we know the appropriate amount of pollution generation, we can also talk about the fee, how much of fee level is to be imposed on the polluters of pollution. Okay. So normally there will not be a spontaneous market to supply the right amount of pollution. Okay, so if it did, its individual would have received a compensation equal to marginal damage functions per unit of the pollution, and the farm would pay marginal savings per unit of the pollution. That is the idea. So in that case, what will happen? The farm, this will induce the farm to generate the current amount of pollution. But that is normally not the case. So if we assume that the farm paid minus MC extra per unit of pollution, but paid it to the government instead of to the consumers of the pollution, this should result in the correct amount of pollution being generated. And since consumers cannot affect their exposure, the fact that they are not compensated is irrelevant for efficiency. Okay. So what we can define about Pigouvian fee as a fee which is paid by the polluter per unit of pollution, exactly equal to the aggregate marginal damage caused by the pollution when evaluated at the efficient level of pollution. This fee is generally paid to the government. Okay, so this can be shown with the help of a diagram out here in the next page if you look into. So this is a diagram. Actually here what we are considering is there is one polluter. There are two victims in essence you can say so. So which are victims of pollution? These two people. In the lower half actually we are trying to show the marginal cost of pollution. Basically it's a kind of negative one. So where with higher emission, the marginal cost, extra additional cost of pollution generation has come down. So the opposite of this marginal cost curve is the marginal savings curve, which can be represented in kind of quadrant 1 as MSX, which is negative of marginal cost for pollution or emission. So here emission and pollution are simultaneously used. Then another curve we are trying to find out is the marginal damage curve. And for the individuals, two individuals, we have two individual marginal demand functions. So MDIX, where there are two individuals. So MD1X is for the first individual, and MD2X is for the second individual. Now, each of these marginal damage schedules or functions is upward sloping. So the interpretation is something like this. When pollution levels are relatively smaller, one more unit of pollution, it causes very little damage. Okay, so that's not very important at that point of time. But with higher emission level, okay, pollution levels means like, when pollutions are higher, any extra unit will be causing or resulting in more damages. Okay, so that's why it will damage will be higher and higher. Additional damages will be higher and higher. So that is why these damage functions will be a positively sloped curve. So pollution is a public bad. So aggregate marginal damage, like the aggregate demand, will be the vertical summation of individual marginal damage function. So that is why we find this MDX curve to be above the MD1X curve and MD2X curve. So these are actually vertically added together, aggregated, and we arrived at MDX curve. So the optimal amount of pollution, as we have seen, is arrived at a point where MS X star or MSX is just equivalent to summation of the marginal damage function. Now here, in this case, we find a point which is corresponding to an emission level of X star. And this extra level is also associated with a price of P star. Of course, this price, we have to find out what this price is all about. In essence, we can say that this P star is nothing but the Pigovian fee. Okay. So when the polluter is charged P star per unit of pollution, the polluter will try to see pollution as priced at P star. That means, so if somebody is emitting an emission level of X star, he is to pay a price of P star. Okay. So otherwise, what we can say, if we consider this pollution to be an output of the farm, then okay, so output is normally it's a demand function or maybe supply function. The curve can be considered to be a supply function, basically because this is kind of cost, and this marginal savings function can be considered to be a demand function. Now, so this supply and demand will determine a price, and this X or maybe emission can be considered to be an output level. So in that case, P star will be the price that the polluter receives. But of course, in that case, this if it is price, then obviously we can consider this to be negative price, because ultimately this is a fee which is to be paid to the government. Okay. So normally we know that a farm produces so that the price equals the marginal cost. So in that sense, it will be MC extra will be equivalent to minus of P star, or we can say that MS extra is equivalent to P star. So the amount of total fee that the farm will be paying to the government will be given by multiplication of this P star with the amount of emission, or in a sense you can say P star into extra. That will decide, that will actually tell us the total amount of fee which is paid by the farm for pollution to the government. So there is another alternative interpretation, or in a sense you can say the view of looking into the problem. So it's something like this: without the Pigovian fee and without any other market or regulations to restrict pollution, the farm will basically see a price of zero for pollution. Okay, if there is nothing like that, because normally we are talking about this pollution fee only when the government is imposing, right? So when the government is saying that you are generating this much of pollution, so that's why you need to pay this much of pollution fee or Pigovian fee. But in the absence of any such mechanism, okay, so there is no price for pollution. In that case, price is zero. So from the farm's point of view, it will be optimal to respond to a zero price by producing where marginal cost is zero, because price is zero. So we normally see that the optimality will be arrived at, okay, equilibrium between, or kind of means in fact the marginal cost being equivalent to the price. Since there is no price out here, then obviously price is zero. If price is zero, then you can say that emission is also equivalent to zero. So our price is zero, marginal cost is also equivalent to zero. So here, so if somebody has to reduce pollution, now in this case, when we are talking about marginal cost to be equivalent to zero, marginal cost will be equivalent to zero at the x-axis. So the output or maybe pollution generated will be equivalent to x cap out here. Okay. So if somebody wants that the pollution is to be reduced, then the cost of pollution is to be increased by raising the fee. And as the fee is raised from zero, pollution generation gradually declines until we are. It means that in the absence of any restriction mechanism, the farms will be interested in uh, not paying any price. So in that case, they will be interested in producing at the level of X cap. But if the pollution has to be restricted, so then the price has to be increased. And the price goes to that level of Pigouvian fee, P star, at X star amount of the pollution generation. So pollution will be reduced from X cap to X star, and the fee to be paid to the restricting agencies or maybe kind of controlling agencies will be equivalent to P star. So this way, in fact, this P star will try to discourage people from generating more pollution and more production of goods and services, which are actually associated with generation of pollution. So, but the fact is that here we need to understand one thing: the Pigovian fee, as we are defining or trying to define, is not any emission fee. It's definitely an emission fee, but the fact is that this is not any emission fee. It is the marginal savings from pollution at the optimal pollution level. Okay, so it's an emission fee, no doubt, but it's not an any emission fee. It is the marginal savings from pollution at the optimal pollution level. So that optimal pollution level is more important. For example, X cap here, X cap is not the Pigovian fee, because X cap something means, in fact, pollution generation has happened out here, and there is no price for that. So obviously this is not Pigouvian fee. But if you come to X star, so that is the Pigouvian fee, because that is the optimal amount of pollution which is to be generated in the society at large. So the point where this marginal damage function is just equivalent to marginal savings function. So that point will decide how much will be Pigouvian fee, and that is why we say that Pigouvian fee will be associated with the optimal pollution level. Otherwise, it cannot be considered to be a Pigouvian fee. Is it okay? So once we have this idea of Pigovian fee, probably we can go to the concepts of tradable permits and liability law again once more, right? Just give me a minute. Can you see the slide now?
Yes, sir.
Yeah. Now, we talked about this tradable permit, and tradable permit, we say that in the case of tradable permit, the authority will be deciding on how much of pollution will be kind of allowed in a particular location. And once that is decided, then after that, the authority will issue the number of permits to the polluting agencies or polluting industries. Okay, so initially, depending upon the number of industries, okay, pollution permit will be decided. Because suppose if in a particular locality, suppose 10 units of pollution is sought to be generated from a particular industry, particular type of industry, so individual farms in that industry will be issued permits corresponding to the amount of pollution to be generated by them. So the industries will purchase permits based on their requirement, because ultimately it is directly the number of permits required is directly proportional to the amount of pollution or emission to be generated by the farm or the industry. So that way it goes. If somebody generates more pollution, he or she has to purchase more number of pollution permits. If somebody else generates a little bit less, then he or she will have to purchase a little bit less number of pollution permits. That is how it goes. So initially there will be some kind of initial distribution of permits between different polluting agencies or polluting farms. But after a certain point of time, depending upon the efficiency of the individual farms or industries, the requirement of pollution permit will be changing. And based on that, some relocation of the pollution permits will take place. So that is what is written out here. A marketable permit or tradable permit allows polluter to buy and sell the right to pollute. Trading induces a price or a value on a permit to pollute, thus causing farms to see pollution as an expensive activity. Less pollution means fewer permits need to be bought. Similarly, there is an opportunity cost of emitting. That is, by not emitting, the farm can sell more permits. So that is the opportunity cost. Okay. So if you are emitting less, so you require less number of permits. That means the extra permits that you might be having, so that you can sell and you can get some revenue out of that. So for that, one illustration has been given. So that is shown in the figure out here. So here, what we are trying to do is to assume a situation where there are only two pollutants or polluters, and for these two polluters, 100 units of pollution in total have been decided in the area. So initially, each of the farms are given 50 units of permits, and the equilibrium price of permit is considered to be at PISTER level. So this is the situation out here. This is the uh, graph which shows us the economic incentives, in a sense, tradable permits. Okay. So on the two means in fact, see, the vertical axis are basically marginal. They are talking about farm 1 and farm 2, and the marginal savings uh, uh, from left to right. If we try to read out in the case of x-axis, we'll find the number of kind of means savings, marginal savings in a sense, you can say so. So what is happening out here? These two marginal savings functions to the for the two farms have been drawn in such a way that any point along the horizontal axis gives the number of permits each farm holds. Basically, marginal savings function you can see from the Pigouvian fee kind of a thing. So where we are saying that marginal savings function will be falling. For farm 1, this is actually falling from left to right. For farm 2 again, so we are talking about this. So marginal savings function is falling from right to left. It's something like this. So for farm 1, we can read from the left, and for farm 2, we can read from the right. The total of holding of the permits will be equivalent to 100. So for farm 1, we can read it from left to right, 0, 50, star 100. Similarly, for farm 2, we can read from right, so 0, probably star, then 50 to 100. So this is farm 2's holdings. So initially, we are talking about a situation of 50-50 units for each of these two farms, right? Now, what happens? You see, initially, although we are finding that okay, each of the farms are having 50 units, but after a point of time, since kind of purchasing of pollution permit is a costly affair, no farm will be interested in spending more on purchasing permits. They'll be trying to control pollution. If they find that pollution control is relatively easier, so then they will go for pollution control rather than purchasing permits. Okay, so if farm A is more efficient in doing that, of course, here we are talking about farm 2. Suppose farm 2 is more efficient in controlling the pollution. So in that case, farm 2 will be requiring less number of pollution permit than 50 units that it initially purchased. But for other farm, for example, here farm 1, the pollution control activity is not so efficient. So it's not it is not in a position to cut down pollution cost quickly compared to farm 2. In that case, the pollution permit price might be less compared to its kind of pollution control cost. If it finds that so they are better off by purchasing more number of permits than controlling pollution, as the pollution control cost is higher, then they will be trying to purchase more of permits. So that way, although initially each of the farms were having 50 units of pollution permits, but now probably farm 1 will be requiring more number of pollution permits, as they are not so efficient in cutting down the pollution level, or maybe pollution control cost is much higher out there. So they will be happy to have more number of pollution permits, whereas farm 2 are considered to be more efficient in cutting down the pollution cost. So in that case, so they will be kind of better off by selling, okay, by releasing some of the pollution permits. Since the total number is 100, the extra additional number might be required by the other farm, and accordingly, the new relocation will happen at Easter level. Okay, so that is how this tradable permits work. The relatively efficient farms will require lesser number of pollution permits, whereas relatively inefficient farms will be requiring more number of pollution permit. Okay, so here farm 1 will be holding Easter number of pollution permits, whereas farm 2 will be holding 100 minus Easter number of pollution permits. So the equilibrium price for trading out here will be P star. So in essence, if you look at, we find that this P star can be considered to be a Pigouvian fee. In essence, we can say that an emission fee of P star will achieve exactly the same outcome. Okay, suppose there is a little uncertainty. So with an emission fee, we know precisely what the marginal cost of control will be. We are less sure about the quantity of pollution in the case of emission fee. That is the thing. But in the case of tradable permit or marketable permit, we know exactly how much pollution there will be. We are less sure of the marginal cost of control for the individual farm. Okay, so that is the issue out here. So in essence, we can say that both these things are more or less similar in nature. The pollution permit, marketable permit, as well as Pigouvian fee might be serving the same purpose out here. Just a minute, huh? Just a minute. The third type is the liability. We have discussed about this, I think, in one of the previous classes. In the case of liability, the basic principle is that the government or maybe the controlling agencies will not specify what kind of precaution is to be taken by the individual farms or the entity which is dealing with certain kind of hazardous items, for example. Here, the idea is that if you harm someone, so you must compensate that person for the damage. That is the idea out here. So here, it means that when somebody undertakes a risky activity, he or she will have to take all potential damage from the activity into account when deciding how carefully to perform the activity. Okay, so that is important. Now, here the controlling agency will not tell you how much precaution or how much of care has to be taken up by anybody. But the fact is that you are considered to be responsible for any consequences. Okay, this creates an incentive to be careful when undertaking any risky activity, and in fact, to take the socially desirable amount of precaution in undertaking such risky activity. Now, to illustrate this, here an example has been taken. So basically, it is considering a hazardous waste storage facility, for example, dump. The dump can do things to minimize the risk of hazardous waste leaking into the environment through precaution. Because you see, so if we know that we are dealing with some hazardous items, these hazardous items might at any point of time create problems for the society at large. So what is expected is that these type of mishaps or kind of problem do not happen or do not occur. So for that, it is the responsibility of the industry or the farm to take sufficient precautions. Okay, so they can they can do things to minimize the risk of hazardous wastes leaking into the environment through precaution. Now, when you take precaution, if the dump takes sufficient precaution, so then obviously the risk of leakage will be relatively low. But at the same time, when you say precaution, so appropriate mechanism has to be there, or maybe kind of appropriate care has to be taken. So that is a kind of expensive activity. And precaution is expensive. You have to spend something for that. Ceteris paribus, the dump would prefer to take little precaution. Normally, so interest will be to take little precaution until and unless there is something which is happening and which can be very much damaging to the society. So another thing is from the point of view of society, if we talk about damage, so damage depends on the level of precaution. If sufficient precaution is taken, the damage probability of damage from the dump or maybe storage of the hazardous item will be relatively less. Okay, so let's see the diagram out here. This is a diagram out here. Now here two things are shown. One is there are two curves actually. One is the cost of precaution for the farm, which is represented as CX, and the other one is the expected accident cost from precaution, or in essence you can say the damage, which is shown as DX. Now X is the amount of precaution. If more precaution is taken, the expected accidental cost from precaution will be less. So that is why this accident cost curve or damage curve, so that is a kind of negatively sloped curve from left to right. So higher precaution means lesser amount of damages. Okay. And the second one is the kind of cost of precaution. If more precaution has to be taken, okay, more preparation has to be there, and more additional items will be required, or maybe additional settings are to be set up. So that means that more cost will be added, so total cost will be going up. So that is why the cost of precaution is an increasing cost. It's an increasing function of the amount of precaution. Now, there is some socially desirable level of precaution which can be considered as extra, so at which the marginal cost of taking more precaution are just offset by the reduction in marginal damage from taking more precaution. So in essence, we can say that this will be kind of marginal cost of precaution being equivalent to the marginal damage function, which again gives us the kind of optimality that we are looking for. Okay, so liability works like this. That so we have to tell the dump, do whatever you want, but should an accident occur, we'll find the socially desirable level of precaution. If you were not taking that level of precaution, you will be responsible for all the environmental damage from the accident. That means the government or maybe the controlling authority will not tell you anything how much of precaution the farm or the industry has to undertake. It is the responsibility of the farm to ensure that sufficient precautions are taken so that the damage to the society will be the minimum if there is a kind of leak. Okay. So this is how negligence liability works. There might be some other liabilities also, but basically we are talking about the negligence liability out here. So here there is a threat. This threat of being held responsible for accident damages. So that is often a sufficient incentive for farms to take the socially desirable amount of pollution. It's a precaution. So socially desirable amount of precaution will be taken only because of this threat which is being given to them. So that is how this liability law works. So we have studied for both the command and control policies as well as the economic incentives, the measures of pollution control. So these things we have already discussed. Probably we have discussed. I just forgot whether I discussed these things or not. In the case of economic incentives, there are certain advantages. We do not require enormous amount of information. In case of command and control, of course, we require enormous amount of information because so based on that only the controlling authority will decide, okay, what kind of measures will be sufficient for controlling pollution. But here, since there are economic incentives for each and every farm, okay, so that's why it's the responsibility of the farm to look into their requirements and accordingly, okay, decide on an appropriate measure of controlling pollution. So here, economic incentives might provide an incentive for a polluter for innovation, for finding out cheaper ways of controlling pollution. So that is missing, totally missing in the case of command and control policies. In the command and control policies, the centralized agencies will dictate what is to be done, and accordingly, the individual farms have to respond. Okay, so otherwise there will be penalties. But here, in the case of economic incentives, it is the amount of pollution which are generated by the individual farms. Okay, so that is why, because if any farm generates more, then it will be responsible for paying more amount of taxes or maybe fines or whatever it may be. Or maybe you have to purchase more number of permits if you are generating more pollution. So all these things are costly for the farms. So for reduction of the cost, overall cost of production, so they will be trying to go for better methods. So they will try to go for more innovation. Economic incentives also involve the polluter paying not only for the control cost but also for the pollution damage, because here we are trying to equate this marginal control cost being equivalent to the marginal damage function. Basically, we are trying to minimize the summation of the control cost as well as the damages. So that way, in fact, these economic incentives will be trying to take into account both the pollution amount as well as the damage. Both the things will be taken care of. But in the case of command and control policies, that is not the case. So we mostly go by the command and control. So that's why there is very less regard for taking into account the marginal damages existing from the pollution that is happening out there. Another thing is that for many economic incentives, the equimarginal principle holds true. We're talking about this one, no? Marginal control cost equivalent to marginal damage function. So that means kind of marginal functions are equal across farms. So that is one principle which is considered to be one prerequisite for optimality. So that holds good in the case of economic incentives principles or maybe kind of instruments. But there are certain disadvantages. So that is why actually these economic incentives instruments are not very popular amongst the many developing countries out there. Now, these are some of the kind of disadvantages of economic incentives. So developing an economic incentives that efficiently and perfectly takes complexities in environmental transformation into account can be very difficult, because so there are a lot of issues out there, no? So kind of pollution generation and emission. So these are also not directly connected as such. They are connected, but actually emission and pollution are two different things. And pollution generates or maybe results in damages. Emission probably will not be directly resulting in damages. So those things are there. Complexities are more prominent out there. So uh, so there those complexities of environmental transformation cannot be accommodated okay kind of sufficiently in the case of economic incentives. That can be accommodated to some extent, but actually designing or developing such an economic incentive will not be very easy thing. Okay, another issue is that so what should be the level of incentives? For example, the fee, level of fee, number of marketable permits, so all those things. So who will decide this? Centralized agencies should decide this. But the fact is that they will also be subjected to a lot of political pressure. So given the political conditions, it will not be very easy to adjust the level of incentives when there is a great deal of uncertainty associated with the environmental problem. We know about that. Kind of in the environmental problem, there are a lot of issues in the form of space, in the form of time. Okay. So things in Kerala might be a little bit different from Punjab. So that is why actually kind of having a kind of economic incentive instrument or designing an economic incentive instrument will be a little bit tough. Okay, to talk about the level of incentives will be a little bit tough. Another thing is that we know about this transfer of money from the farms to the government. So you see, so when you talk about this economic incentives, so for example, we are talking about Pigouvian fee or pollution fee. So these things involve a lot of money, and this money has to be transferred from the individual farms to the government. Obviously, so when there is huge amount of money, huge amount of kind of money to be transferred from the farms to the government, then obviously there might be certain issues out there. So instituting this type of tax on emission may be very difficult as it involves this type of issues. So an emission tax generates a tremendous amount of revenue for the government administering the tax. So it might be good for the government, but instituting such a tax may be very difficult politically, precisely because of the wealth transfers. Uh, so that is why we find that substantial emission fees may have gone, may have not gone anywhere in most of the market economies. Uh, so that is another reason, which is why command and control policies are considered to be uh, they are the most popular one amongst all forms of pollution control measures. So although we find that pollution controls can be done in a better way in economic incentives instruments. So because there is a kind of so many positives are there in the form of kind of incentives given to the polluters or producers, or maybe kind of taking into account these marginal damages and marginal costs. All those things are taken into account out there in the economic incentives instruments. But in spite of all these things, the popularity of economic incentives hasn't been that much. Even today, command and control policies dominate the field of environmental regulation or pollution control. So basically, there are issues in administering this type of economic incentives in a kind of a feasible manner, and at the same time, okay, kind of administering command and control policies might be relatively better because you do not have to look into so many things out there. But in the case of economic incentives, there might be issues out there. So these are some of the things which we need to know before talking about the relative advantages and disadvantages of these different types of instruments on pollution control. So the complexities in pollution control should be discussed, and probably tomorrow in tomorrow's class we'll take into account that there are a lot of complications for environmental regulation. There are issues of space, there are issues of time. Efficiency issue is one important issue. Effectiveness issue is another issue. So those things we need to look into. Because you see, so when you talk about the pollution control, no, so we are, although we are saying pollution control, we try to control the emission. But its emissions are taxed, or in essence, we can say that we impose a restriction on emissions. But emissions are not directly responsible for damages. It's the ambient pollution which are responsible for, which is responsible for damages in the society, let's say public health or whatever that may be. So these are the issues. So that is why it's important to control pollution. But actually, the policies which are adopted normally, so they are concerning the emission generation because it is the source which results in pollution. Some of the emissions, if you look into, we talked about by way of natural processes that happens at many point of time. Waste, for example, it may not be direct emission gas kind of a thing. It might be waste, which might be solid, which might be kind of dumped into a river or maybe water bodies. So the oxygen level which is present in the water, so that might itself take into account. Okay, converting this damages or maybe kind of waste into harmless substances. That is done. So that way, in fact, there are things so by which the emissions can be converted into, some of the emissions can be converted into harmless substances, and the residual amount which is not converted into harmless substances may be responsible for pollution generation or ambient pollution generation. Now, this ambient pollution generation is responsible for creating problem with the human health or human welfare. So that needs to be controlled. But there is no direct way of controlling that pollution. Rather, we have actually we have the ways of controlling the emitters or the emission level. So that is a kind of complication out there. But even then, there is no other kind of shortcut method to control pollution. So that's why we go by controlling the emission level out there. We'll try to take note of these things in tomorrow's class. In the meanwhile, if you have any question, any issue as of now, I welcome your observations or questions or opinion on this. Please. Do you have any question on this so far? Any observation, any question on this?